Good morning. So we are still looking at projectile motion. So the thing is, when you're looking at projectile motion, you should know how to define projectile motion, where we define projectile motion to be the motion of an object that has been thrown at a certain angle and it is being acted upon by gravity. So this body is going to be thrown into the air at a certain angle and it will be acted upon by gravity. So this definition is going to be very important when we start analyzing projectile motion, the motion of a body thrown at an angle being acted upon by gravity. So what are some of the key principles that you need to know under projectile motion? So principle number one, you should know that projectile motion is in two dimensions. This simply means there is part of the motion that occurs in the x-axis and there is part of the motion that occurs in the y-axis. So therefore, for all the vectors that we're going to come across under projectile motion, you should find the x component as well as the y component of the motion. So whenever you're given a question on projectile motion, you should analyze the motion in the x, also analyze the motion in the y axis. Remember, when we're looking at 1D, the equations that we used to use were v is equals to initial velocity plus at. The other equation was displacement is given by the initial velocity times time plus 1 over 2 at squared. And then the last equation was the final velocity squared is equal to initial velocity squared plus 2as. These are the equations that we used to apply under 1D. And then we said for you to apply these equations, we said that object is supposed to be moving in 1D and the acceleration of that body is supposed to be constant. So when the acceleration of this body is constant and the body is moving in 1D, we are able to apply these equations of motion. So even under projectile motion, since we'll be analyzing the motion in the x separately from the motion in the y, this simply means we are also able to calculate or use these equations to analyze motion. So when you're analyzing the x-axis, you get these same equations, then you modify them so that they are aligned with the x-axis. You can also use these same equations, you modify them so that they are aligned with the y-axis. So these are the same equations that you are going to be using. So we analyze the x-axis separately, you also analyze the y-axis separately. So when you look at these equations, since projectile motion is in two dimensions, our main focus will be resolving all the vectors into the x component and y component. And what are some of the vectors that we have in here? So you have your velocity, you have your acceleration, you also have your displacement. So you should know how to handle your velocity, you should know how to handle your acceleration, you should also know how to handle your displacement. Time is a scalar, it does not point in a specific direction, so you won't be able to resolve the x and y components of the time. So principle number one is, remember to say the motion that we are looking at is two dimension. So you analyze the motion in the x separately from the motion in the y, and these are the equations that we are going to be applying. Now, how are we going to be handling these same vectors? Number one, let's start with the acceleration. How are we going to handle the acceleration under projectile motion? So we know that acceleration is a vector and this motion that we are looking at is two dimension. Therefore, you're supposed to have the acceleration in the x. You're also supposed to have the acceleration where? In the y axis. Okay? So to know the acceleration in the x and the acceleration in the y, we'll go back to the definition where we said projectile motion is a motion of an object at an angle being acted upon by gravity. And we all know that gravity is always pointing downwards in the y-axis. So this simply means that if this body is only being acted upon by gravity, meaning there will be no acceleration in the x-axis. That's why the acceleration in the x-axis is always going to be 0, because this body is being acted by gravity, which is only found in the y-axis. And the acceleration in the y-axis is going to be your gravity, which can either be positive or negative. So since we are saying that the gravity is always pointing downwards. So this is your gravity that is always pointing downwards. When this object is moving up, it is opposing gravity, the gravity is going to be negative g. When the body is moving downwards, the gravity is going to be positive. That's why we're saying the acceleration in the y can either be positive or negative g. So you just choose one depending on the motion of the body, because we want this acceleration to be constant. So number one, the acceleration in the x is 0 and the acceleration in the y is positive or negative g. So that's the first thing that you should know under projectile motion. The acceleration in the x is 0 and the acceleration in the y is gravity. Then number two is the other vector that we have is your displacement. Or let's start with the velocity. You have your velocity. Again, for the velocity, you're going to have the initial velocity. You're also going to have the final velocity. So you have your initial velocity, you're also going to have the final velocity. So for the initial and final velocity, you're also supposed to find the x and y components. So we are saying for the initial velocity, you're supposed to find the initial velocity in the x. You're also supposed to find the initial velocity in the y. Same applies to the final velocity. You're supposed to find the final velocity in the x. You're also supposed to find the final velocity in the y axis. Okay, so we were looking at vectors. We know how to find the x component. We also know how to find the y component. We also know how to find the x and y component. Okay, so how do you find the initial velocity in the x? We said for you to find the initial velocity in the x, what are you supposed to do? So to find the initial velocity in the x, we said the initial velocity in the x is going to be given by the initial velocity cos theta. For you to find the initial velocity in the y, you say the initial velocity in the y is going to be given by v of sine theta. So for all the questions that will come across, always remember to resolve your velocity into the x component and the y component. Same applies to the final velocity. You should find the final velocity in the x, also find the final velocity in the y. Okay? And then how do you find the final velocity in the x and how do you find the final velocity in the y? There are two equations that you can use here. You can say the final velocity is equals to the initial velocity plus at. Okay? So number one, you use the same equation to find the final velocity in the x. You also use the same equation to find the final velocity in the y-axis. So when we use this equation to determine the final velocity in the x, whatever is in this equation here is supposed to be for the x-axis. So where there is final velocity here, I will say final velocity in the x is going to be equals to, here where there is initial velocity also, this is initial velocity in the x, plus where there is acceleration is supposed to be acceleration in the x multiplied by time, where we said time is a scalar, so there will be no x and y component. So this simply means your final velocity in the x is going to be equals to, what is the initial velocity in the x? The initial velocity in the x is what we determined here. It's going to be VO cos theta plus, what is the acceleration in the x? We said the acceleration in the x is 0. So this is going to be 0 multiplied by your t, meaning the final velocity in the x is going to be given by VO cos theta. Okay, so if you look at the formulas for the initial velocity in the x and the final velocity in the x, it's just the same thing. So since the acceleration is 0, that's why the initial velocity in the x is always going to be equals to the final velocity in the x. So we are saying the first step is you resolve the velocities into the x and y component, and these are the formulas. And then from here, you also determine the final velocity in the x, you also determine the final velocity in the y. So the formula that you can use is, you can use this formula here and say whatever is in this equation here is supposed to be for the x-axis. So the final velocity in the x-axis is equal to the initial velocity in the x plus acceleration in the x multiplied by the time. Then where there is initial velocity in the x, we got what we calculated here, v or cos theta. The acceleration in the x, we said it's 0 multiplied by the time. So meaning this is a formula that you're going to be using to calculate the final velocity in the x-axis. And then the other formula that you can use to determine the final velocity in the x is you can also use this formula where you said the final velocity squared is equals to the initial velocity squared plus 2ms. So if you want to find the final velocity in the x, you just modify so that whatever is in this equation is for the x-axis. So you say the final velocity in the x squared is equals to the initial velocity in the x squared plus 2 times the acceleration in the x. Then the displacement here is supposed to be for the x-axis. So multiplied by the displacement which is in the x. So we've just used the same equation and then we've modified it. Okay? So mean what you're going to have is final velocity in the x is going to have, what is initial velocity in the x? We said this is v or cos theta, and this has been squared, is equals to 2, or this is plus 2 times what is the acceleration in the x? This is 0 multiplied by x. So meaning the final velocity in the x squared is going to be equals to, this will give you 0. So you're going to have v or cos theta squared. So if you find the square root of this, also find the square root of this, you have the final velocity in the x is going to be equals to v or cos theta. You still get the same thing. So one thing that you should understand here is that the final velocity in the x and the initial velocity in the x are going to be the same since there is no acceleration in the x-axis. So that's how you find the final velocity in the x. Then from there you can also find the final velocity in the y. So how do you find the final velocity in the y? Again, you can apply these two formulas. V is equals to VO plus AT. You can also use this formula. V squared is equals to VO squared plus 2AS. Then you modify these equations for the y-axis in this case. So if you are looking at this equation, you will say the final velocity in the y is going to be equals to, this will be initial velocity in the y plus, where there is a, it's acceleration in the y multiplied by the time. So meaning the final velocity in the y is going to be equals to, what is the initial velocity in the y? We said it's VO sine theta plus, what is the acceleration in the y? We said plus or minus g. So I'll just say plus or minus g gt. Meaning when the body is opposing gravity, you just get the negative. When it's towards gravity, you just get the positive. So this is the formula that you use when calculating the final velocity in the y. Okay? So these are the things that we will be using to solve any questions. So know how to handle your velocity. So you're saying for velocity, it has the initial, it also has the final. We know how to find the x and y components of the initial. We also know how to find the final for the x and the final for the y. So for the final for the x, this is the formula that you are going to be using, of which it's similar to this one because there is no acceleration in the y or in the x-axis. And then how do you find the final velocity in the y? This is the formula that you're going to use. Final velocity in the y is equals to the initial velocity sine theta plus or minus g. So here you just choose one, whether the gravity is positive or negative. You can also use the same equation here to find the final velocity in the y. So it's just one and the same thing. And then for some questions, they'll also ask you to find the magnitude and direction of the final velocity. They'll ask you to find the magnitude and direction of the velocity. So how do you find the magnitude and direction of the final velocity? So having determined your final velocity in the x, you've also determined the final velocity in the y. You can't fail to find the magnitude and direction of the final velocity. You can say the magnitude of the velocity is going to be equals to the square root of the final velocity in the x squared plus the final velocity in the y squared. So this is the formula to be using to find the magnitude of the final velocity. Then for the direction is going to be given by the arctan or tan inverse the final velocity in the y divided by the final velocity in the x. So this is how you find the magnitude and direction of the final velocity. You know how to determine the final velocity in the x. You also know how to determine the final velocity in the y. So this is for the magnitude and this is for the direction. Then the other thing that you're supposed to know, the last one is know how to handle your displacement. Okay, so for the displacement, if it's for the x-axis, you're going to be using x, and if it's for the y-axis, you use y. Okay, so for example, if you have this equation which is displacement is given by the initial velocity plus 1 over 2 at squared. You can apply this equation for the x-axis. You can also apply this equation for the y-axis. So when you apply this equation for the x-axis, this simply means where there is s, you will say x is equals to where there is initial velocity, supposed to be initial velocity in the x times the time plus 1 over 2 the acceleration in the x and then t squared. So meaning x is going to be equals to what is the initial velocity in the x? We said it's supposed to VO cos theta multiplied by the time plus 1 over 2. What is the acceleration in the x? We said it's 0, t squared. Okay, so what you're going to have is x is going to be equals to VO. So we are using this one which is here. So we are going to have VO cos theta multiplied by the time plus this is going to be 0 on the other side because the acceleration in the x is 0. So meaning x is also going to be VO cos theta multiplied by t. So this is how you find the displacement in the x axis. This is the formula that you're supposed to use. You can also use the same equation which is s is equals to VOT plus 1 over 2 gt squared for the y-axis. So mean whatever is in here now will be aligned for the y-axis. So where there is s here, you say y is going to be equals to where there is initial velocity, you say initial velocity in the y multiplied by the time plus, so this is supposed to be a here. So you have 1 over 2 the acceleration in the y, and then you have t squared. So meaning your y is going to be equals to, what is the initial velocity in the y? We said it's VO sine theta multiplied by the time plus or minus 1 over 2 gt squared. So plus or minus is for the g. You choose whether it's positive or negative depending on the motion of the body. So this is the key to projectile motion. Know how to handle the vectors. So we've looked at the acceleration in the x to be 0, the acceleration in the y to be plus or minus g. When the motion is towards gravity, it's going to be positive. Opposing gravity is going to be negative. From there, we moved on to look at the velocity. Know how to resolve the initial velocities into the x and y, and know how to find the final velocity in the x and how to find the final velocity in the y. So how do you find the final velocity in the x? This is the formula that we use, and this is what we got. How do you find the final velocity in the y? We use this formula here, and this is what we got. And know how to find the magnitude and direction of the final velocity. These are the two formulas for the magnitude and direction. And then how do you find the displacement in the x and displacement in the y? you use the general equation. So we started with the x-axis, we analyzed everything with respect to the x-axis, and the final formula that we got is this one, which is here. We also applied the same equation for the y-axis, and this is the final equation that we got. Okay, and then from there now, you'll come across different sketches. So when you know the sketches and you know the principles that I'm from talking about, then you'll be able to solve any question under projectile motion.